Welcome to the course MCDM techniques using R. So, in the previous lecture we started our discussion on VIKOR. We talked about some of the introductory aspect of VIKOR, and then we started our discussion on the steps that are required to be executed to implement VIKOR method to do VIKOR modeling. So, let us do a quick recap of what we discussed in the previous lecture. So, as we have talked about in the previous lecture that VIKOR is quite similar to TOPSIS in terms of procedure, and in terms of the way both VIKOR and TOPSIS are classified, compromise ranking method, they are also classified as distance based method or reference based approach. So, all these aspect we have talked about. Then we also talked about the VIKOR, what we obtain from the VIKOR modeling, the compromise ranking list, the solution, and then the weight stability intervals, and all this through a ranking index, which is measuring the closeness with respect to the ideal point, quite similar to what we did in TOPSIS, where we were looking for the closeness of the best alternative with respect to ideal point, and looking for the whether farthest point, the best alternative should be farthest from the anti ideal point. So, this is also VIKOR is also similar, but we only focus on the ideal point. We also talked about the LP metric, which is actually used to define the metrics that are actually used in VIKOR. So, we talked about SK and RK, and we also talked about how these two measures are then finally used as boundary conditions in the final metric, that is QK. So, we also discussed the feasible solution, the compromise solution, and the how it is determined in terms of through this graphic, right. So, then we started our discussion on this the VIKOR steps. So, first, as we talked about that best and worst F values need to be computed for all criteria. Then we can go ahead and compute SK and RK values for all the alternatives. Then we talked about the QK metric, which is and the introduction of a new parameter V, which is weight of the strategy, typical value being 0.5. So, we talked about how a balanced approach is taken in terms of these two boundary measures SK and RK, and how this weighted sum based on SK and RK is computed here. So, this also we talked about in the previous lecture. Then these three measures S, R and Q, they can be sorted and will get 3 ranking list. However, our focus is mainly on the Q, which is the main measure in VIKOR for obtaining ranking. So, then the last step of VIKOR is the most important one, which we started a discussion on it. So, how do we propose a compromise solution? So, we talked about that alternative A dash, it can be ranked best using measure Q. So, as we said that we typically focus on this Q based ranking. So, first we will look at the sorted list that is produced based on Q values, and we will obtain the first ranked alternative, which is A dash. So, the minimum value of Q is actually the first ranked alternative. Now, to accept this alternative A dash, the first ranked alternative based on Q as the compromise solution, two conditions are to be satisfied, C1 and C2. So, in the previous lecture we were discussing C1. So, where C1 is about if Q A double dash minus Q A dash, this should be greater than or equal to DQ, whereas as we talked about in the previous lecture that A double dash is second ranked alternative and A dash is first ranked alternative. So, this difference between the Q values of these two alternatives should be within this should be greater than this acceptable value. So, this scenario is referred as acceptable advantage. So, if the first ranked alternative is having higher value than this much higher value than in comparison to second ranked alternative, then we can accept this. Our second ranked condition should also be satisfied. So, what this second condition C2 is about. So, here the alternative A dash should also be ranked best using S and R measures. So, yes, S and R major there also the ranking is based on we identify the alternative with the minimum value. So, that would be first ranked alternative, just like Q, just like ranking based on Q. So, S and R also we can do the same, and we have to check that the alternative A dash which was found to be the first ranked alternative based on Q, whether it is the same case in for S and R. So, if this is also satisfied, then we can go ahead and accept A dash as the compromise solution. Let us talk about different scenarios for C2. So, A dash is actually stable compromise solution given a voting scenario. So, we talked about that V being the weight for the strategy. So, here you can see different scenarios that could be there for different strategy. So, if voting by majority rule is only accepted, then the value of V is to be greater than 0.5. If the voting is by consensus, then value of V should be approximately 0.5. If even lesser vote than 0.5 is accepted with vote, then just the the alternative with the largest number of vote kind of scenario would be taken as the compromise solution. So, these are three scenarios that could be there, and different values of V would actually indicate this these scenario. However, when we say that stable compromise solution, what we essentially looking for is that the alternative that is to be decided as the best alternative, it should be same in S or in it should not be just in Q, it should also be reflected in S list or R list or in all three lists. So, either Q and S or Q and R or Q, S and R. So, if in all three list a particular alternative A dash is ranked best, then we can say this is a stable compromise solution. So, across ranking it comes out to be the best one. So, this is what this scenario is referred as acceptable stability in decision making. So, three different measures S, R and Q, and if all three ranking list based on these three measures, if the proposed alternative is comes out to be the best, then we can accept this stability. So, two important aspect of VIKOR method is that the ranking and the compromise solution that we produce is with a advantage rate. So, you can see DQ, this is indicative of the advantage rate, the acceptable advantage, and then the acceptable stability in decision making, that is also part of VIKOR. So, the proposed solution will actually reflect these two aspects as well. So, what happens if either of C1 or C2 is not satisfied? Then how do we go ahead in terms of proposing the compromise solution? So, if you look at the previous two conditions that we talked about, C1 and C2, it is C1 which is more important and C2 is more of a complementary condition. So, if only C2 is not satisfied, then you can see that alternatives A and A dash and A double dash can be proposed as the compromise solution. So, it would be not just a solution, a set of solution. So, A dash and A double dash as a set would be proposed as compromise solution. So, this is the scenario if only C2 is not satisfied, that means acceptable stability is not there, but at least because C1 is satisfied, at least A dash and A double dash they can be proposed as the compromise solution. But what if C1 is not satisfied, then we have to look for alternatives starting from A dash, A double dash to A n. And how do we know where to stop? How do we determine this A n? So, this is determined by this relation as you can see in the slide, Q of A n minus Q A dash. So, the difference between the first ranked alternative and the nth ranked alternative, that should be less than dq. So therefore, these alternatives, they would be positioned quite close to each other. So therefore, it makes sense to propose all these alternatives as the set of solution. So these n alternatives would be closely positioned, and therefore these alternatives can be a dash to a n, they can be proposed as compromise solution. So this was the last step in VIKOR. So finally, what we obtain is a ranking list of alternatives and the solution with the advantage rate, right. So these are the main steps of VIKOR, and you can clearly see how it is different from TOPSIS. However, both these techniques share quite a bit similarity in terms of procedural steps. However, there is some big differences as well. So what we will do now, we will open our studio, and whatever we have learned through these VIKOR steps, we will try to implement in an R studio exercise. So the example that we are going to take is the same one like we did in TOPSIS, ranking of cars. So we have these 3 alternatives and we have these 4 criteria. So the same data set, the same example we are going to take. So let us open our studio. So VIKOR in R, it is actually implemented in MCDM package. So that is the only package that has VIKOR implementation. TOPSIS, as we talked about, we had 3 packages for TOPSIS. So we saw 3 exercises for TOPSIS in that lecture. However, this is just one package we have for this VIKOR. So the goal is ranking of cars. We have 4 criteria: purchase price, economy, aesthetics, and boot capacity. And then we have 3 alternatives right here. So just like in TOPSIS, first we need to have these scores, the performance table. So as you can see here, we are going to use this matrix function, and within the matrix function, the first argument we are trying to generate using the another function, that is C. So with respect to these 4 criteria that we have, you can see the values have been given there, and this matrix is going to be a 3 cross 4 matrix, where 3 is in the number of rows, which is equivalent to the number of alternatives. So alternatives are going to be displayed on the row side, and the criteria are going to be displayed on the column side. Alright. So we have 4 criteria. This becomes 3 cross 4 matrix. So let us run this code. So you can see here the matrix has been generated, and you can also see that across column 1, across along the column 1, the values are in similar range. Column 2 values are in similar range. Similarly for column 3 and column 4. This is how you can actually cross check whether the way you wanted your matrix to be generated, whether it is coming out to be the same. Now we can also define the row names and column names after the alternative and criteria names, so that we can easily identify which value is associated with which criterion and which alternative. So you can see this matrix and how the values are associated. Now criteria weights. So sum of all these criteria weights would be 1. So you can see here. Now weights are being initialized using this combined function, C function. If you sum all these values, 0.35 plus 0.25 plus 0.25 and plus 0.15, so this comes out to be 1. So these are the weights that are being given. So if you look at the values, 0.35, this is the highest weight. So highest weight is being given to the purchase price. So decision maker, they would like to give highest preference for the purchase price criterion, followed by economy and aesthetic having the 25% weightage, and then the boot capacity is the last one. So let us initialize this. So this is weights is done. Now let us also rename the these values, so that we will get to know which value is associated with which particular criterion. So, now we have created the matrix with performance score and also weights for criteria. Now, let us move ahead. Now, just like in other techniques also, we need to specify the preference direction for each criterion. So, whether a particular criterion is of representing benefit or whether the criterion is representing cost. So, if it is representing benefit, then it is to be maximized. If it is representing cost, then it is to be minimized. So, that has to be indicated using another variable here. So, this variable that we are using is criteria min max. So, here again we are using the combine function, the C function, and for each of the criteria we are going to indicate this direction. So, first one is min. So, because this is purchase price, so we would ideally like to minimize the price of a car, and so therefore, min has been given. So, this is this criterion is actually representing cost. So, we would like to minimize it. Then we have economy. So, this is a performance parameter. So, we would like to maximize this. So, therefore, with respect to economy criterion, max has been indicated. Similarly, for aesthetics and boot capacity, so these are also two parameters of car which we would like to maximize. So, let us initialize this variable as well, criteria min max, and names of let us also associate names, so that we will know which criterion is associated with which preference direction. So, you can see here now. Now, the package, as we said for VIKOR modeling, the only one package that we have in our environment is MCDM. So, let us load this library. So, this is loaded. Now, we talked about in our discussion that there is this parameter V. If we go back to our discussion, so we talked about this, that different scenarios for V. So, here you can see voting by majority rule. So, we would typically be greater than 0.5. Voting by consensus, so V is approximately 0.5 or 0.5, just 0.5, or with vote, then V less than 0.5. So, here we are taking V as 0.5. This is the typical value that we take in VIKOR. So, for our exercise we are taking V as 0.5. So, let us also initialize this here also, because this value is going to be used in the computations in VIKOR. So, now we are going to build our VIKOR model. So, here you can see VIKOR function is available within this library. If you want to understand more detail about this particular function, you can go into the help section here, and we will just type VIKOR, and we will get the details. So, VIKOR. So, we just type the VIKOR. So, you can see here in the help section, VIKOR is part of MCDM package. So, this is for implementation of VIKOR method for multi-criteria decision making problem. So, if you look at the usage of VIKOR, so there are 4 arguments as you can see in the help section. First one is decision, then weights, and then CB, then V. So, decision is actually nothing but the decision matrix of values of F alternatives for the n criteria. So, that we have already generated the performance table that we have. Then the second argument is weights. So, this is a vector of length containing the weights for the criteria. So, sum of the weights has to be 1. So, this we have already checked there. So, this has been generated. Then the third argument is CB. So, this is actually a vector of length n. Each component is either CBI max, or if the criterion is benefit, or min if the criterion is cost. So, this part also we have already initialized. So, this part we have checked. Then the fourth argument is a value in the range of 0 to 1. This is V. This is our part of the calculation of Q index, as we have talked about. So, these kind of details you can always find in the help section, and once this function is called, so what is the values which are going to be returned. So, you can see here value VIKOR returns a data frame which contains the score of S, R and Q indices. So, we will get the scores of these three measures S, R and Q, and also the ranking of alternatives. So, this is the output that we are going to produce if we use this particular function. So, let us go back to our modeling. So, first argument is performance table as we have already created, then weights, then criteria min max and V. So, let us run this. So, now here you can see we have the column number. So, in the first column we have alternatives 1, 2, 3, and then we have the values for S. So, for alternative 1 is 0.4, then for alternative 2 0.66, for alternative 3 0.725. So, from this particular list it seems that first alternative is the best one. If we look at the R values, then alternative 1 0.25, alternative 2 0.35, and then alternative third is quite close value to alternative 2, this is 0.346. Our best is the alternative 1. If we go by the Q values, which is the main metric in VIKOR. So, this is 0.00 for alternative 1. So, this is the lowest. So, alternative 1 seems to be the best alternative. Then the value for alternative 2 is 0.899 and value for alternative 3 is 0.98. So, if we go by, if we follow the steps that we talked about in our slide, then if we just look at the list by Q values, then alternative 1 is the best one. And if we if we check the second condition, so let us first check the first condition. So, if we look at the difference of second best alternative, so this is 0.899 and the first alternative 0.00. So, the difference is 0.89, and if we look at the what would be the DQ value, since the number of alternatives here is 3. So, if we compute the DQ value, it comes out to be 0.5. So, you can check back the formula again. Let me show you. So, this is the formula for DQ, 1 divided by n minus 1. So, since we have 3 alternatives, so it will become actually 0.5. So, if we go back, so difference between first alternative and second alternative, this is greater than 0.5, and if we look at the first condition C1, so this is what we actually wanted. So, this difference between first second alternative and first alternative is greater than the value of DQ. So, for condition 1 is satisfied. So, if we look at the second condition, which says that the alternative A dash should also be the best alternative at least in S or R, and if it is in both, then even better. So, we can see here in the list produced using R values and in the list produced using S values also, the alternative 1 comes out to be the best alternative. So, therefore, this acceptability condition that is there, acceptability stability, this particular that we talked about. So, both the conditions are satisfied, C1 and C2 both are satisfied. So, therefore, we can say that compromise solution as per VIKOR modeling here is this first alternative, the Corsa car. So, this is the modeling, this is how we can actually do our modeling for VIKOR in our environment. So, as you have seen here using this VIKOR function, we need to have these 4 arguments, these scores, and then the weights for the criteria, and then the preference direction for those criteria, and then the value of parameter V. So, with that we will get the values for these 3 measures S, R and Q, and by analyzing the results of these results, we can find out if the conditions C1 and C2 are satisfied or not, and then we can confirm our compromise solution. So, this is how this can be done. Now, let us go back to our discussion. So, we will discuss a few more points about VIKOR. So, few important aspect of VIKOR that we can discuss here is that ranking may be performed with different values of criteria weights. So, as you have seen in the function that we have even in our environment there, that criteria weights are being taken as an argument in the function. So, therefore, we can always change the criteria weights and again do the modeling and we will get the results. So, therefore, it is easier even in our environment as well to analyze the impact of criteria weights on the proposed compromise solution. So, this is akin to sensitivity analysis that we talked about. Preference is stability of an obtained compromise solution. So, similar point that we can change the criteria weights and look at the interval for those weights where the compromise solution is not going to be changed. So, this is one aspect of VIKOR. Now, when this particular technique could be useful, important aspect of VIKOR we have already talked about, that it just not produces the ranking list or best alternative, it will also give us the advantage rate. So, that is one aspect that we have already discussed. However, if the decision maker is not able to or does not know their preference at the beginning of the decision problem that they have, then probably VIKOR can help in that sense, right. So, this is one aspect where VIKOR can be useful. Now, if we look at the results that are obtained through VIKOR, the resulting ranking index. So, we look at this is an aggregation of all criteria. Remember how we how the expression SK, how the measure SK is formulated mathematically. So, if you remember that and then remember QK and RK, then you will get the idea that this is an aggregation of all criteria, quite similar to the other techniques that we have discussed so far. Then relative importance of the criteria, so that is also part of it, right. As we have seen in the steps, a balance between the total and individual satisfaction. So, in the QK measure that we talked about, so there we saw that a balance between the maximum group utility and minimum individual satisfaction that was incorporated in the way QK score was formulated mathematically, right. So, maximum group utility represented by mean S of the majority and a minimum of the individual regret of the opponent. So, balance between these two is also part of this VIKOR modeling and the resulting index that we produce. Then VIKOR, if we look at VIKOR more conceptually, so this can be considered as a competition where inclusion or exclusion of an alternative could affect the ranking of new set of alternatives. So, because the way it is the way procedure is implemented, the comparison with the ideal solution, all the alternatives being compared with the ideal solution and the way whole approach is taken, right. So, in that sense this is this ranking is like a competition, and if you introduce a new new candidate there in terms of a new alternative, then of course, it is going to impact the final result. Now, because of similarity in terms of procedure and in terms of the way they are categorized, we need to understand the we need to understand and compare these two techniques, VIKOR and TOPSIS. So, if we talk about in terms of the aggregating approach that is part of the procedures of these two techniques. So, aggregating function same, this is based on LP metric, but different forms. So, if we look at VIKOR, this is based on L1 and L infinite. However, if we look at TOPSIS, it is based on L2. So, you remember that in TOPSIS we had used Euclidean distance formula also, and the way the final the closeness ratio was formalized. So, that is actually bearing close similarity to L2. So, different forms of aggregating function LP metric are used in these two techniques. Different kinds of normalization are done to eliminate the units of criteria. So, VIKOR is actually uses a linear normalization. So, what is the advantage of linear normalization is the normalized value that we get does not depend on the evaluation unit of criterion. However, we look at TOPSIS, it uses vector normalization. So, the normalized value could be different for different evaluation unit of a criterion. So, this is how the normalization approach is different in these two techniques. If we look at the distance computation that is there. So, as we talked about LP matrix, the way it is formulated, it is like a representation of distance between the alternative and the ideal solution, right. So, this how distance is actually computed in these two techniques, let us discuss this. So, VIKOR solution is based on closeness to the ideal solution. However, if we look at TOPSIS, it is based on the shortest distance from the ideal solution and the farthest distance from the negative ideal solution. So, therefore, two distances are incorporated in TOPSIS, whereas we only focus on one different distance, one type of distance in VIKOR. So, another issue with TOPSIS could be that it does not consider the relative importance of these two distances. So, how how the distance from the ideal solution and how the distance from anti-ideal solution, how that importance, how that relative importance is to be determined. So, that is actually not that is actually one issue in TOPSIS solution. If we look at the solution that are obtained from these two techniques, VIKOR, we get the highest ranked alternative which is closest to the ideal solution. However, in TOPSIS we get highest rank alternative which is which is best in the ranking index. So, this because two distances are part of this solution, the way the solution is generated in TOPSIS, it is not guaranteed that as per the ranking index in TOPSIS, the best alternative that we get, it is always going to be closest to the ideal solution. So, that is one difference over there. So, with this we complete our discussion on VIKOR, and in the next lecture we will start our discussion on another MCDM technique. Thank you.